All right, let's jump right in. You ever look up at the stars and just, get that feeling there's way more going on than we can see?
Oh, absolutely. All the time.
Well, today we're diving into something truly massive, a cosmic collision called the Bullet Cluster.
Ah, yes. Fantastic example.
Think like two enormous clusters of galaxies smashing into each other. Cosmic bumper cars, basically.
Yeah, that's a good way to put it. A very, very big collision.
And it's incredible because this event, this smash-up, it's actually giving us some of our best clues about, well, something invisible, dark matter.
Exactly. It's a natural laboratory for studying it.
So our mission today is to sort of unpack how this huge event helps us understand all that hidden stuff in the universe.
Right. So picture these two galaxy clusters colliding. Billions of stars in each one.
Okay.
But stars are tiny compared to the space between them. So when the clusters met, the stars themselves, they mostly just sailed right past each other.
Like ghosts passing through walls, almost. Not much interaction there.
Pretty much, yeah. Like two swarms of bees flying through each other, maybe. Most bees just miss each other.
Okay, I get that. But the clusters aren't just stars, are they? There's all that gas and dust in between.
And that's where it gets really interesting. That gas and dust, which is actually most of the visible matter. It didn't just sail through, it slammed together hard, lots of friction,
So that stuff interacted. It slowed down.
Dramatically, it created this massive shock wave, heated the gas up to millions of degrees.
Oh, millions.
Yeah, so hot it glows brightly in X-rays. So we can actually see where that ordinary matter, the gas, ended up. It's lagging behind where the stars went.
Okay, so stars went one way, the visible gas cloud got stuck kind of in the middle, glowing hot. Makes sense.
But then came the puzzle. Scientists looked at how the whole cluster bends light from galaxies far behind it. Gravitational lensing.
Right, where massive things warp space-time and act like a lens.
Exactly. And they expected the strongest lensing, the strongest gravity, to be where the most visible matter was that big hot gas cloud.
But it wasn't.
It wasn't. That was the shocker. The strongest gravity, the main gravitational pull, wasn't centered on the gas at all.
So where was it?
It was much closer to where the stars had passed through, out ahead of the gas cloud.
Wait, so the gravity is where there's less visible stuff? How does that work?
Well, that's the billion-dollar question, isn't it? Or maybe trillion-dollar, cosmically speaking.
Yeah.
If gravity comes from mass, and most of the visible mass is in the gas cloud, but the gravity isn't strongest there.
Then there must be some other mass we can't see.
Bingo. Enter dark matter. This invisible stuff, whatever it is, it has mass, so it has gravity.
But it doesn't interact with light or collide like the gas did.
That's the idea. It would have just sailed through the collision along with the stars, totally unimpeded.
So the dark matter and the stars traveled together, leaving the normal matter gas cloud behind.
Precisely. And because dark matter has so much mass, its gravity dominates. So the gravitational lensing effect follows the dark matter and the stars.
Wow. So the bullet cluster literally separated the visible matter from the invisible dark matter.
It really did. It's like catching an invisible hand leaving its gravitational fingerprint. It showed dark matter isn't just some tweak to gravity theory. It's actual stuff that got physically separated from the normal stuff.
That's huge evidence.
It's considered one of the strongest pieces of evidence we have for dark matter's existence. And we think, based on this and other observations, that dark matter makes up something like 85% of all matter in the universe.
85%. That's mind-boggling. Most of the universe is stuff we can't even see.
It's incredibly humbling, isn't it? We look out and see all these stars and galaxies, but that's just like the tip of the iceberg.
Yeah, a tiny, tiny tip. The bullet cluster really drives that home. There are these profound cosmic secrets just hidden in plain sight, gravitationally speaking.
Absolutely. It highlights how much we still have to learn.
So it really makes you wonder, doesn't it? Here's something for you, the listener, to think about. If most of the universe is this dark matter, how radically would things change if we finally figured out what it is?
Yeah, imagine if we could actually interact with it somehow. What else might we discover out there? What other secrets are waiting?